All right, we can get started. You all hear me? Okay. Sounds good. Okay. So recording on. Sounds good. Thanks. So my name is Shailesh Toshi. I'm a senior solution architect with AWS, and my colleague Izat Karimi, who couldn't be here, but she played a big role in preparing the presentation and everything. And today's topic, I want to talk about efficient row-level security in databases. So notice it is databases. So we'll talk about, at one point we'll talk about multiple different engines and compare side by side how it works. We also want to talk about RLS, in short, row-level security. What's the architecture? Why do it? How to do it? What's the multi-tenancy is a big thing in the market right now. It has a lot of benefits. In fact, next door, I think they're talking about multi-tenancy in depth. So check out their session as well. So pros and cons of RLS, and then optimization and best practices on like how to best do it and what to watch out for, right? Then we'll talk a little bit about Gen AI and how that helps with RLS or finer grained security, as well as how you can do Gen AI better with RLS. So we'll talk about both sides. So what is RLS? Restrict access to specific rows. We all know that. So typical table, you have, sometimes you have a need to control access to each individual row depending on who the user that is accessing or updating the data. So restrict access to sensitive data, right? So PII and all of those things are becoming more relevant now, and those requirements are showing up. Then support multi-tenancy is another thing. So if you have a model where you have multiple tenants that are sharing the environment, then you want to make sure that different tenants' data is isolated. And we'll talk more about multi-tenancy in a bit. So the other thing that you may hear in the similar context is column level security, and we'll go a little bit deeper into that too. So row level limits the rows. Essentially, it creates another filter, and you run the SQL, and it says, oh, this user has access to that one row only, or has access to no rows or whatever. Column level, you can say grant to certain individual columns to user or role. So the way it works is you have a table, you define a policy, and then you have in the policy you have a predicate. So that predicate is evaluated to decide if the current session is able to view or what data they are able to view or change. Now, there may be other techniques like PG crypto, for example. Let's say you had some PII data, credit card number in a table. You could say PG crypto that column, and that would be another way to do something similar like restrict access to individual column. All right, so here is an example. Select star from products where user ID equal to current user. So whoever has the session, their ID is taken, and then it is evaluated. The equality is evaluated, and you may or may not have access, right? So that's how it really works. So user 1 may have access to something, user 2 may not. That's really the RLS basics. So this is what it may look like user 1 has access to 2 rows in this case, and user 2 would just have access to 1, and so on and so forth. There may be other scenarios, like for example, I've seen a use case where a user can see, let's say it's a HR table, you can see your own salary in the table, but nobody else can, so that would be typical use case. However, your manager and manager's manager, your hierarchy can see that too. So you can set up the predicate in such a way that the level you can say is greater than or equal to your level, then they can see that data, right? Yep, so that's that. RLS definition and implementation. So what do I mean by that? So on the left-hand side, you see all those components that go into setting up RLS. And on right-hand side, you see different ways or techniques where RLS can be possible. So what are the components? Security policy, right? So we said create table, alter table, enable row level security, and then policy. Policy is most important. You have no policy, you have no access. Then a row level security function or predicate. So you can have plain predicate SQL, or you could have a function. Like, for example, there could be like current settings function, right? So you can grab something from the current session and you can evaluate access based on that.
I think we lost the screen.
Oh.
It's on the wrong slide. There we go.
Oh, okay, cool. Thank you. Then next is table access, right? And then row filtering, that happens at the end. So your SQL is evaluated by the optimizer, and then at the end it will apply this row level filter and then give you the data that passes through the filter condition. On the right-hand side, you see different ways. So row level security functions, so we talked about functions. Views, that could be another way you can implement something similar to row level security. I have seen systems where you can have, when a new user or tenant comes in, a certain view is created automatically, and then that decides what access they get as they go through their session. Stored procedure, of course, any logic that you can have in function, you can put it in stored procedure as well, and pass on the current user as a parameter to the stored procedure. Triggers, of course, ABAC and RBAC, right? So ABAC is attribute-based access control, and RBAC is role-based access control. So the role part is pretty clear, straightforward. What's attribute-based? So nowadays, and I work with some customers in healthcare, life science space, and one of the requirements is certain users can see data based on their physical location. So if I am in Ohio, I can see some data, but same person, if I go to Illinois, I cannot see that data. And those are like GDPR. Europe has a lot of such requirements. So how do you implement those things with attribute-based access control? All right, so next one. So what does the code look like, right? So here you can see that the code has essentially the parts that we talked about. Alter table, of course, we have to do that. Policy name, table name, permissive or restrictive, right? So what is that? So you can potentially have multiple policies for the same purpose. So let's say you want some users to view the data, but only less number of users to be able to update the data. So then you can create two policies. And then the restrictive would mean there is an end condition applied. So both of them have to succeed in order for that action to happen or be allowed by that user. What are the commands that are in scope for access control? Basically, you can do all or select, delete, insert, update. All is default if you don't do anything. It's interesting that, how the engine would react in Postgres. You try and insert something and row level policy denies that, then you would get an error. But if it was a select or update, you would pretty much get no error. It would just say 0 rows. So that's just how the engine works. So now the other thing to note is row level security does not apply to some things like commands that are at table level. For example, truncate or references, when you have one table that references the other. So those things are out of scope for RLS. Using expression, so that's or role, I think we missed that. So role is really, if you don't say anything, default is public. Um, and using expression, that's really the core piece of it. And then check expression. So you can do either using or with check. So for updates and inserts, it's really the check expression. So here is one example when you put all of that together. All right, so policy types in Postgres, permissive and restrictive. So we talked about that. When you have multiple such roles, you want to make it restrictive. What is bypass RLS, right? So you would have table, you would have an owner of the table. They have the bypass RLS. But if you put, you can essentially say force on that policy, then it will be applied to even the owner, but not the super user though, right? So they are out of scope for that.
So you're saying that an owner of the table can then have a row level security applied to them?
By doing a force.
Wow.
Yeah.
Okay.
Yeah. Which is not generally, you would think owner should have. Yeah.
Full access.
Yeah. Yeah. So different platforms, right? So here is a little bit of side-by-side comparison. You can see, I won't go through everything, but just look at the left side column and see the different criteria or the feature that we are comparing, right? So what does the enablement look like? It's inbuilt in the engines. By the way, on the right-hand side is OpenSearch. So I work in an analytics space, and OpenSearch is one of the very popular analytics service where you work with documents, right? So it's a JSON and it's a semi-structured. So what you do, a row here in a database is really a JSON document in OpenSearch. So you can do things like document level, which is row level equivalent policies. You can also do column level, which is field level security in OpenSearch. And you can say include and exclude both in OpenSearch. So other three are just relational, pure SQL structured data engines. So fine-grained access control. So we'll go through the slides pretty quickly. We already talked about ABAC and RBAC. Yep. So so RLS and fine-grained access control. So you can see, so this is an example of the location, right? So I was talking about the tag attribute-based. So this is where you can set that up and restrict the permissions based on location in this example.
So this is just an additional filter based on.
Yes, exactly. Right.
This I understand that kind of new to Postgres, so you have the roles for applying whether you have access to what objects you actually have access to and whether you can write to them or not.
Yes.
And then you can put in the policy to determine who the owners are, so it's either the fine grain or it's filters also.
Correct. So fine grain is really at the end. That's evaluated at the end. Yeah. So multi-tenancy, a couple of isolation models, and we won't go in detail for the multi-tenancy. Basically, the isolation modes are silo. So you have like complete infrastructure that is replicated for each tenant, or you could have pool, and pool is where really row-level security becomes very important because multiple tenants are sharing the same environment. There is also something called as bridge, which is something in between. And in Postgres terms, I've seen people refer to as you have different schemas, and each tenant gets one schema. So that's like a compromise between the two. So I'll just go through this real quick. In isolation model, you have pool isolation. This is where different tenants are sharing the database. So, and that's where you would put something like this. And tenant one queries would be something based on the tenant's use or the setting, and then tenant two would have tenant two query. So pros and cons of RLS. Data security by default, right? So this is done at the server level. compliance with regulation, fine-grained control, dynamic access control. Because why dynamic? Because you could set it up with users, and now the more users you add, it's dynamic. You don't have to do anything. It just says user equal to whatever is the user, right?
Do you have a slide?
Oh, sorry.
Yeah, it's okay. Thanks.
Yep. So I think my slides are getting a little messed up. Benefits of RLS, or okay, I'll just go by that. Benefits of RLS. Yeah, we went through that. RLS challenges, right? So, what are some of the challenges? Is the added complexity, because now you have to think about this extra layer that you have added. It's not in the application. It's not really purely in the data, but it's somewhere in between, right? So you have the data model that you set up and the permissions and authorization, and then you put RLS on top of that. So too many rules, too many policies, it could be hard to manage. Performance, so if you do explain plan, you can see if you had too many layers of policies, things start to slow down for your queries. When to avoid RLS? So let's say you have static data. Data doesn't change much, So you really need to ask yourself, do you want to take that extra overhead of management and certain performance hit? Because every query that runs on that table is going to evaluate RLS policy, right? So avoid complex engineering or over engineering, auditing and logging. So some people start to use this for auditing, but really there may be other ways to better audit the system access than just doing RLS. And encryption, I think the last line was encryption. So we talked about things like PG crypto, for example. That may be an alternative to manage selective access. So optimization and best practices. In best practices, you can see simplify the security policies, create index on security predicates, right? So because it's evaluated at each select or each command, when you have that set up, it may help you with the creation of the index. You can try and do caching. So like, for example, you can create a materialized view on the predicate part. So now it's really in materialized view cache, in other words. So your queries will benefit from that. So these are some of the RLS optimization best practices, as to say. So let's talk about RLS and GenAI, right? So I think we have like 2 minutes. So there are a lot of things in GenAI that can benefit from RLS. So what is GenAI application, right? So you have the application, you have the model, generative model on one side. The user is asking questions, they get response. Sometimes you have hallucination. In order to avoid hallucination, you put a RAG database in between, so it becomes more contextual for your use case, right? So that RAG database could be something that has a role-based access control. And now you can control how much data that particular user of a chatbot or some kind of GenAI application can really see. So you can limit that at a fine-grained level. On the other side, GenAI can benefit from like looking at different access patterns, looking at data classification, looking at compliance. So when you look at all the data, and then you can say, hey, there is a risk, potential, threat here. So let's put in RLS policy in this area, right? So you can have GenAI do that work for you of the assessment. You can also use GenAI to generate the code for policies. You can say, hey, here is my table, generate code for me, right? So model would do that. So this is, these are some of the ways where you can use in both directions. So some of the takeaways really factor in the scale and performance when you're designing for RLS. use RLS for enforcement access control only and not like your main access control mechanism by design. Keep it simple. Test and measure the impact, right? So as your database grows and it evolves, you may want to make sure that you measure the impact of RLS. Follow the best practices that we talked about. And avoid RLS if you know it's not really required. Use GenAI to improve RLS. And if you're using GenAI, consider RLS to limit the responses and answers that the users of GenAI get, depending on whatever their role or persona is. All right, so on the dot, any questions? And I have our emails up here. If you think of any questions in the future, feel free to contact us. The PowerPoint should be uploaded on the session website or the page. Any questions? You think you might use RLS pretty soon, or have you had any experience doing row-level security?
Well, PGCron uses it, so I mean they kind of use it
Internally, yeah.
Yeah, it sort of inherently.
Inherently, yeah.
Yeah, because it's built in.
Right, right.
So
Yeah, I've used views when I need to limit access to stuff. I mean, I can definitely see a benefit, like you were giving an example, when you have lots of users, you
Yep.
want them to only see just their information on that one table. It wouldn't make sense to have 100 views for that, nor could you really create one view that then says, you know, well, this particular user,
Right.
you know, whatever, because that's not within the.
Yeah, it's not scalable and dynamic, yeah, yeah. And the other way that we didn't go much in detail, when you have, let's say, a client-server application and database, right? So what you can do is, like I said, the config, you can get the current settings. It's a function that you can use, and then you can say set config. So on the application side, you can have set a pool of users, and then you can selectively say, here is a parameter that I'm going to pass to the backend session as the session is opened. And then on the backend, you can do RLS based on the parameter that's passed. So now the application could have thousands of users, but it really knows each session, and it can really control access for that session. But if you are using something like PG Bouncer, for example, like a server session pooling, then you may want to be careful, because then you don't really have much control over like exactly what session you get. So then that setting would have to be really thought through.
Most of my experience, I mean, I'm a big fan of roles, and so I usually use a combination of roles and security groups. But I've used roll-up security like for storing Power BI.
Yeah.
Not usually on a database level, just because it can get a little tedious. I mean, I've done that before, but
and then you forget that it's there, and you're like, oh my God, where's the data?
Right.
well, and I oftentimes use OneNote for my change control, because sometimes I see like sometimes those roles, the changes, it's just like it's easy when somebody can do that manually, how you can change it. That's effective. Mainly just people that keep track of it. But yeah, it's a combination. I mean, this is a good environment. They need for someone to know who's in it, and they need to know what they can access it. It's straightforward.
Yeah. Yeah, so there are pros and cons. Like you can do that access control in like front-end Power BI or some app, but you are potentially bringing more data to the session front-end and then filtering at that point. And so there is, the network and the memory and all of that, and the performance, right? Whereas this would be done on the back end, so much faster, much more efficient, but less flexible and less manageable in that sense.
Yeah, no, I definitely like the fine-grained access control. That's definitely the filters.
Yeah.
It's not so much that I'm not willing to do the work. What the problem is it's the relationship with the business team.
Right.
To get them to sign off on exactly what it is, whether that's the source of what I'm not doing. They'll say, why can't I see this? And it's like, well, someone on your team approved this filter a long time ago.
Right.
And then you forget about you, just like you're saying, something you don't remember. And it's like all of a sudden, oh shoot, there's like another 2,000 users or like accounts that you should have seen.
Right, right. Yep, that's
Yeah,
definitely,
right. I mean, no, overall, I think it looks like a very solid process. I'm just saying that unfortunately, given all of that, I think it's worse than.
yeah, definitely, yeah. Yeah, so, yeah, you have to
One
evaluate.
other thing I was gonna ask is there a view that lets you see what the security policy is for the user or for the particular rows?
Yeah, I don't know off the top of my head, but
But there is one?
there should be one, yeah.
Yeah, because I could totally see that being a problem if like somebody implemented it and then an app, app dev comes and man, we're not getting all these.
Right,
rows,
yeah,
we're
so
not-"
why is that, yeah?
Yeah, kind of similar to what you were talking about there, don't remember it or forgot that that was put in place.
Yeah, there should be a catalog place where
There's a catalog
it
to see it.
should be, yeah, it should be, yeah. I haven't checked, but there should be one, yeah.
Cool.
But,
I
more,
I just feel like sometimes a lot of it, you're asked to do more and more with less and less time. And
Yeah.
This sort of stuff, you have to really sit down and have time to kind of think about what you're doing.
yeah.
You can't just slap it in place, and that's probably why people do probably simpler, stupider solutions.
Yeah, and over a period of time, things evolve, right? So you start off with some app, and it was great when it was created, and then business evolved, and now requirements have changed, and nobody took care to like redesign some aspects. So, yeah. Well, thank you, gentlemen.